Hello students, this is a quick maths video about the free response question number 5 from 2008, the AP Statistics exam. It was all about moose. This is a relevant picture, of course. Alright, so the question was talking about a study being conducted to determine where moose are found in a region containing a large burned area. You've read the question already, hopefully. So here's the information. We know that number 1 is inside the burned area, not near the edge. Number 2 is inside the burned area, that's near the edge. Number 3 is outside the burned area, that's near the edge, and then outside the burned area, but not near the edge. So these are the 4 different, they call them habitat types. These are just areas in the region. And then the proportion of total acreage in each of the habitat types was determined for the study. So this is the proportion of total acreage out of the acreage which is actually not given to us. And this is the number of the number of moose observed out of a total of 117. So they didn't tell us like, it was like 5 square miles or whatever, but they said it's about 34% of the total acreage. This is 10.1% of the total acreage, so that you understand what's going on in this table. So for letter A, it says the researchers who are conducting the study expect the moose to be proportional to the amount of acreage to that type of habitat. So for example, if it's 34% of the acreage, there should be 34% of the moose here. They found 25 moose. If it's 45.5% of the acreage, there should be 45.5% of the mooses. Moose? Moose, right. Are the data consistent with this expectation? So the thing that we're going to do is we're going to conduct a chi-square test for the number of moose observed in each habitat. Chi-squared, goodness of fit specifically, but remember you don't really have to say which chi-square test you're using. In this case, you just need to know how to use it. In this case, we have some observed values, and we also have some expected values. Here's how to calculate the first expected value. Well, it says here that they expect the number of moose that are observed to be proportional to the amount of acreage. So in other words, 34% of the acreage is in habitat type number 1, the burned area not near the edge. So that means they expect the number of moose observed to be 117, which is the total, times 0.340, that's this, and we got 39.78. We'll do that for the rest of the values, but as you'll see soon, you might not have to do that exact calculation over and over again in your calculator. So here are those expected values for each of these. And remember, all we did was we multiplied the proportion of total acreage by the total number of moose. Okay, so there are some differences here. You expect there to be 11.817 moose, but there's 22 here. There's way more observed moose here than there is here. There are fewer observed moose in this area, area number 4, than we expect there to be. So we're not asking why that is. In statistics, we rarely try to answer that question, why, but we are trying to answer, is this consistent with our expectations? So speaking of expectations, let's jump into conducting the appropriate statistical test to support your conclusion. We talked about a chi-square test. It's a chi-square test for goodness of fit. So those H null and HA, the H alternative, are moose have no preference for habitat, which means that the 0.34 times 117 should be pretty accurate. And HA is moose have a preference for habitat. So you could say that the difference between the observed and the expected is really going to be our evidence that we're trying to figure out whether to reject or to fail to reject that H null. Now, of course, we could state that every single proportion of moose that we expect. We could say that we expect the proportion of moose in habitat 1 to be 0.34, the habitat for moose in habitat 2 to be 0.101, but it is time consuming to do that. So we could simplify it by saying moose have no preference versus moose do have a preference. Now next we're going to do the plan step, but luckily for us, our plan step is made a little simple by this piece of information. Assume the conditions for reference are met. So in our plan step, usually when we try to do the conditions, we don't have to do that because all of our conditions are met. We also have to mention that we're performing that chi-square test with an alpha value of 0.05. I just chose 0.05. It didn't have to be that, but that's a typical alpha value that we use. We also know that the chi-squared statistic is the sum of all the observed minus expected squared over the expected. So what we're going to do is we're going to weasel our way out of this by asking the calculator to do it, but pretending that we know how to do it. Not pretending, but by filling out the first and the last calculation. So here's how it looks. So I filled out the first observed minus expected over expected, the last observed minus expected over expected, but I'm not going to fill out the middle ones. It's not necessary for you to do. The calculator is going to do that part. All right, so this is what the chi-squared statistic is supposed to look like. Now, without further ado, I'm going to show you in the calculator how to get that chi-squared statistic. So our first step is taking the observed values and putting them to stat edit. We're putting them into that first list. And in the second list, we're going to put the expected value. So I'm going to do the same calculation as I did before, 0.34 times 117, and I'm just going to press enter. It's going to calculate it for me. So there's my expected values. My list 3, I'm going to ask to have all of the observed minus the expecteds squared. So to save a little time here, I want this L3 to be my chi-squared calculator column. So I'm going to ask my L3, all of my L3 terms, to be my observed, which is L1, minus my expected, which is L2, quantity squared, divided by the expected, which is L2. All right, so now I have all of my components of my chi-squared statistic. Now all I need to do is ask the calculator to add these all together, and I can do that very easily. I have all my values in L3, so I'm going to ask for 1var stats. That's in stat calc 1var stats, and I wanted to do 1var stats for everything in L3. That's going to give us a lot of information, but the important information I'm looking for is that the summation of all the values are 43.68927. Okay, so we found our chi-squared statistic. Now let's see how it applies to the rest of the significance test. And hopefully you'll excuse my chi-squared distribution. It's got to be a skewed right distribution, but I'm no artist. We know that the chi-squared value is 43.68927. That value is here. And what we are looking for, since the chi-squared value is that, we're looking for the area under the curve to the right. We're looking for how unlikely it is. In other words, the area of the curve, the p-value to the right of that. So I jump to my trusty calculator once more, second quit to get rid of all this nonsense, and clear to get rid of all the nonsense. I'm going to go to second distribution. I'm looking for the chi-squared CDF, cumulative distribution function, right? I know that my lower bound is 43.68927. I know that my upper bound is, well, the sky's the limit, right? 10 to the 99th. That's positive infinity. I know the degrees of freedom in this case is going to be based on the number of categories. There are 4 categories, so my degrees of freedom is going to be 1 minus that, which is simply 3. And I don't need any more arguments. All I need is the lower bound, the upper bound, and the number of degrees of freedom. And that gives me 1.75 times 10 to the negative 9th. This is an extremely small number, but you still have to report the number. So here we go. I'm just going to say that the p-value is 1.76, we're rounding, right? Times 10 to the negative 9th. Doesn't really matter though, because this is such an extremely small value. I'm now going to follow up with saying that the p-value is smaller than alpha. Okay, and just like any other test, whether it be a chi-squared test or a test for medians, test for proportions, whatever the test may happen to be, if the p-value is less than alpha, we reject the null hypothesis. Once we make that conclusion that we reject the null hypothesis, we need to sprinkle in some context. So here's what that looks like. We can say that there's sufficient evidence to conclude that moose have a preference for habitat. Because remember, H&O was moose have no preference for habitat. We reject that. All right. So the next part of the question is relative to the proportion of total acreage, which habitat types do the moose seem to prefer? This one is a lot easier, right? We're looking at the proportional values, and it looks like we see 25 moose in habitat 1, but there should be a lot more. There should be almost 40 moose. So habitat 1 has a smaller preference than we expected. There's 22 that we observed, but we only expected to see 11. So there are more moose in habitat 2. Let's highlight that one. We're looking for the habitats that are that the moose seem to prefer. So seem to prefer means there's more moose than we expect. Here there's more moose than we expect. 12 versus 30, here there's more moose than we expect. 40 versus 53, there's fewer moose than we expect. So habitats 2 and 3 seem to be more preferable. Remember, we're going to use our weasel words here. We're not going to say they're definitely preferential. We're saying that they seem to be preferable. And our proof for that is that the expected values of the habitats were lower than the observed values, right? So I'm not just going to say that. This is an AP statistics exam, so I have to back up what I'm saying with solid facts. The expected value of habitat number 2 is smaller than the observed value for habitat 2. Same thing with habitat 3. This number is lower than this number. Give them something concrete, something that they could point to and say, yes, the student knows what they're talking about. All right, that should give you a full credit answer for this problem. That means that's the end of our video. So this was a quick maths video on the 2008 free response question number 5. Good luck studying.